Hello, viewers. I am Dr. Md Mosiqure Rahaman B2. I am a public health professional and epidemiologist working for Director General of Health Services. But this presentation is not my official presentation. I am dedicating this presentation to Dr. Mainuddin, my young colleague, my beloved younger in my medical college, who has been died recently by this deadly coronavirus. Here with some slides, I want to explain my insight, my knowledge, the science which I have learned by reviewing the international journals, documents, presentation, and almost I have taken the information from a renowned scientist, Greg Braden, and Professor Patrick Sun of China, who has depth of knowledge about the science behind this deadly coronavirus. So, in this presentation, in this slide, I would like to give you a little background why this presentation is for. As an epidemiologist, I am an optimistic person by nature, and there are many valid reasons for being optimistic. And we should be optimistic if we really honor what the information is telling us, what the science is. I have realized and inspired by a novel quote by the scientist Greg Braden: when the facts are clear, then the choice become obvious. And that is, if we don't know the facts, if we are malinformed, we are misinformed, the fear will grasp us that the situation prevails throughout the globe as well as in our country. And the fear is an involuntary phenomenon. I hope my presentation will help to alleviate the fears among us in our professional community. In our professional community. So, what are the topics of my presentation? My presentation will highlight what the phenomenon is, what is COVID-19, where does it come from, how it transmits, what it does to us, and what can we do to combat this catastrophic phenomenon. So, first of all, we should understand the virus, what the virus is. And by definition, virus is a very simple, tiny, and very difficult to be seen by microscope. It is made of DNA or RNA capsulated by protein membrane, and it is a long time debate that in the scientific community. All are debated whether it is a living organism or it is not a living organism. It is it causes its living appearance, and you know, to be a living organism there should be certain criteria. A living organism must be made of cells, metabolism, which should use energy, which should grow or develop, which should have capacity to reproduce with a definite lifespan, and of course, it should respond to an external stimuli. And the contrary, the virus is not a cell, no metabolism, no cell replication, no growth, it has no lifespan, need a host cell to reproduce, and it is inert or inactive in nature. And so we should be clear that virus is not a hunter. It does not actively search for us. And what is COVID-19? In this slide, I would like to say that COVID-19 is a disease and complex of phenomenon, predominantly the respiratory symptoms caused by subacute respiratory syndrome coronavirus 2. Here, we shouldn't be confused with the name of the virus and name of the disease. Here I can give you the example. The example is the AIDS is a syndrome, complex syndrome, which is caused by human immune deficiency virus. Like that, COVID-19 is a disease, is a complex syndrome caused by SARS-CoV-2. And here I can demystify the code that COVID, the coronavirus, D for disease, and as it is first identified in 2019, then 19 is added to it. And this virus is a RNA. That means the genetic signature inside the virus, there is a curly RNA that can reproduce in the host cell. And there is a capsule on its surface and spikes with crown. And for this crown, its name is coronavirus. In fact, the origin of the virus, where does it come from? And there are lots of debate. The theory of conspiracy, theory of stigmatization, but from the papers, from the scientific journal, and from the history, we can found that SARS-CoV-2 is the third generation pathogenic novel coronavirus to emerge over the past 2 decades. The first, discovered in 2003 and named as SARS-CoV, caused SARS, a serious and atypical pneumonia. The second, the MERS-CoV, emerged a decade later in the Middle East and caused a similar respiratory ailment called Middle East Respiratory Syndrome, the MERS. Since its identification, there are around 3,000 cases and infection and nearly 900 deaths have been documented so far. The SARS-CoV epidemic proved larger but less deadly, with approximately 8,000 cases and nearly 800 deaths. MERS-CoV and SARS-CoV appear to originate in animals, and the same is likely true for SARS-CoV-2. This makes them a zoonotic disease that can jump between human and other animals. MERS and SARS-CoV were originally bad viruses that spread to an intermediate animal, camel, civet, cat respectively, which is then exposed humans to the viruses. Genetic analysis of SARS-CoV-2 sequences shows that the closest genetic relatives appear to be bad coronavirus, with the role of intermediate species possibly played by the pangolin, an endangered species trafficked in China for its scale and meat, and all the scientific community believed that the market in Wuhan, there are abundant of this type of pangolins, bats. So it may be hypothesized that the virus come from them. And this mutation makes SARS-CoV-2 thousand times more infectious than other viruses of the coronavirus family. And then it is rightly said by World Health Organization Director General that it is not SARS, it is not MERS, it is not an influenza. COVID-19 is a deadly disease caused by SARS coronavirus 2. So the transmission is very important, and scientists identified that an infected person has the ability to contaminate 2.6%. That is, the R0 of this virus is 2.6. The nanoparticles, the droplets caused by sneezing, coughing of an infected person go on surface and then hands and then to our respiratory system. And that is very danger, and that is the matter of fear that our own hands become a vector. However, this is opportunities as well, because and the science of soap, the hand washing, we can we can block the transmission. The virus may directly enters to other with a close distance by direct coughing and sneezing, and the fomites, and then touching by hands and also to the respiratory system. The virus target the respiratory system. The respiratory system, particularly lung, contain the alveolar, which is a gas exchange chamber where oxygen enters when we breathe in and carbon dioxide expels when we breathe out. And this is a very fundamental and crucial act of human physiology. The alveolars are made of alveolar cells, which allow this exchange and which produce basically the surfactant an important element which maintain the tone of the alveolus and making the hole, making the packet, making the sac. After invading the alveolar cell, virus target the ACE2 receptor in the alveolar cell wall and also ACE enzyme, that is angiotensin converting enzyme, on the surface of the cell by their spike. Basically, they hijack the ACE2 receptor and use it as a means of endocytosis. Once inside the cell, the virus particle uncoated and its genome enters the cell cytoplasm. And within the cytoplasm, they can directly produce protein in the new genome by attaching the ribosome in the cytoplasm. The host ribosome then translates this viral RNA to protein, that is RNA polymerase. Thus, this RNA polymerase then become the new positive strand of RNA, which in turn make negative RNA strand, and again it is converted to positive RNA polymerase to positive RNA strand by the ribosome attaching to the endoplasmic reticulum of the cell. And endoplasmic reticulum, after this transcription, they send the whole materials to the cell Golgi apparatus for repackaging, for reproducing the virus structural protein. And by doing this, alveolar cell become affected, they become injured, and they release many chemokines, cytokines, interleukin 2, prostaglandin, and many pro-inflammatory and inflammatory chemicals. So in summary, the coronavirus actually injured the whole lung by damaging the alveolar cell and resulting reduced surfactant, which is, and the alveolus become collapsed. Again, the chemokines, the cytokines also produce pulmonary edema, which ultimately cause hypoxemia, that is low oxygen in the blood, and triggering the baroreceptor or aort, which in the aortic arch, and which ultimately trigger the cardiopulmonary center in the brain to breathe more, to palpate more, that is the tachypnea and tachycardia is occur. So it is also believed that the SARS-CoV-2 also depleted the human natural protective cells like T cells or the natural killer cells, and also they may also reducing our innate immune response, and thus the whole pathophysiology means that by irritating lung parenchyma, dry cough symptom is produced. By inflammatory chemokines, the fever produced, and by pulmonary edema and collapsing lung collapse, there are exaggerated dyspnea and excessive demand of oxygen, and also by tachycardia. So, and by doing this, the infected person can produce thousands of coronavirus and they can transmit it. And the severity of transmission is as such and well documented by the New York Times that they have average R0 is 2.6, which means that if we think that 5 persons are infected, and if they go one cycle, then the cycle 2, the number of patients would be 18, and on cycle 3, number of patients would be 52, and on fourth cycle, number of patients may be 140, and on fifth cycle, the patient means number 300. That is the exponential growth in epidemiological language. And uh, this is very important to shunt or to combat this exponential growth. And the reason, and thus the whole lung have a ground glass appearance, as you can see, and also a fibrosis occur and whole lung become inactive, and this is the reason for the this high case fatality rate of this coronavirus. And again, we can see in next slide that in China, with 44,000 patients, they have found the significant percentage of patients who have been died have the comorbid diseases. So here you can see the early stage case fatality rates by underlying health condition in China. The case fatality rate is calculated by dividing the total number of deaths from a disease by the number of confirmed cases. And the data is based on early stage analysis of the COVID-19 outbreak in China in the period of February 11, 2020. Here we can see the 10.5% of the people with a cardiovascular disease who were diagnosed with COVID-19, and diabetes 7.3%, chronic respiratory disease 6.3%, hypertension 6%, cancer 5.6%, and no health condition 0.9%. So the message is individuals with underlying health condition are more vulnerable with those without the underlying health conditions. Here, this is the map of the patient and the result of China study with 44,000 patients. And here we can see there are three types of patient: mild, moderate, severe, and critical. What we see here that the patient of severe and critical are very rapidly go to intensive care unit, and today even within 3 to 4 weeks. This does not mean that the patient in the groups of mild and the groups of moderate, excluding the chance of death or chance of going to the ICU, though it's a real rare happening. Again, this is a slide showing the age distribution in incidence and the case fatality rates. Here we can see again it from study of China, the mainland China, of 44,672 patients. It is shown that the case fatality rates is highest among the age group over 80 years, and then 70 to 79 age group, and then 60 to 59 age group. But the case incidence is highest in 50 to 59 groups, and then 40 to 49 age groups, and then 30 to 39 age groups, and then 20 to 29 age groups. But in Bangladesh, we have found that the most of the case in these incidents occur on the age group from 21 to 30. And that is the danger. That is the young population. Maybe they are more prone to transmission for their highest exposure in the outside. And this is again the study findings from the mainland China. Unfortunately, we have found the majority of the patients are mild. 80.9% patients showing mild symptoms. 13.8% patients showed severe, and 4.7% become critical. And this is the opportunity. Again, we have to be cautious that we have to avail ICU, we have to avail more trained healthcare professionals, more supplies and equipments for this 80% patient, 18% patient. And this is enormous pressure on our health system, the capacity of health system. So what does the flattening the curves means? And this term is now echoed in the scientific community, in the public health community, the expert community, that we should flattening the curves. The outbreak curves is narrow when we are failed to taking the measures. That is, we are allowing the transmission, allowing the coronavirus for its exponential growth, and that will create enormous pressure on the capacity of our healthcare system. In the contrary, if we can taking the measure announced, pronounced by the science and scientific community, the curve will be under the capacity of the healthcare system. That is, our health system can manage the outbreak by their existing healthcare professional, healthcare manager, public health professionals, as well as the facilities and the equipments without hampering the healthcare system available in the country. And again, uh, this graph is from 55,924 laboratory confirmed cases of COVID-19 from China in the period up to February 22, 2020. Here we can see the signs and symptoms commonly seen. Here we can find that fever, 87.9% of the patients showed fever, 67.7% patients showed dry cough, 38.1% patient with fatigue, 33.4% patient with sputum production, 18.6% patient with shortness of breath, 14.8% patient muscle pain or joint pain, 13.9% patient with sore throat, 13.6% patient with headache, 11.4% patient with chills, nausea and vomiting 5%, nasal congestion 4.8%, and diarrhea with 3.7%. And it is found that many of the most common symptoms are shared with those of the flu or cold. So it is also good to know which common symptoms of the flu or the common cold are not symptoms of COVID-19. And COVID-19 infection seems to rarely cause runny nose. And it is very important for patient isolation, even if the people or the most common people know the common symptoms, they can notice to the health authority to test themselves or even though isolate themselves and to it is very important to know the fever and it is know the dry cough, the signs symptoms of coronavirus or COVID-19. So now I am going for our action, what we should do, what people should do, and what our scientific community should deliver towards the people of Bangladesh. The instruction, what should be our instruction. So I am very much enthusiastic about the science of soap. As we all know that SARS-CoV-2 is an enveloped virus and this envelope is made of lipid bilayer and the soap, regular soap, detergent actually can lyse this lipid bilayer and if we wash our hand, the most basic public health intervention, sanitation, after every exposure for 20 seconds, the transmission, the exponential growth of this SARS-CoV-2 can be limited. And we should be very cautious about the timing, the 20-second, because our hand has many creases which allow us to take more time. That is 20-second. The duration should be 20-second so that this lipid capsule, the envelope, will be cracked. And as rightly said by my elder daughter of standard 6, she said S for solution, O for off, A and P for pandemic. So solution of a pandemic is soap. And that is the irony of the time that once we thought we needed weapons to save the world, but in the end, what we needed is soap. The next thing we should do for curbing, for flattening the curve is the patient isolation. And that is if we found any laboratory confirmed patient or a patient with symptoms of COVID-19, we should isolate that patient so that it is not for him but for others, so that no new patient, no new normal person is being infected from this particular patient. Trace and track, the method experienced by China and South Korea is very important. I will discuss detail in my next slide the South Korean experience of trace and track and the social distancing which also ex- experienced and done by Singapore, Vietnam, very rightly. They have done everything with maintaining social distance of 2 meters or 6 feet so that direct droplet transmission from a infected person, symptomatic or asymptomatic, can be can be blocked, can be checked, because we know the incubation period is very long and it is from 5 to 14 days, and that is huge time for symptom development. Meanwhile, the patient may be infected. Patient may be infected to others. So patient isolation, trace and track, social distancing is a is proven is proved to be a good weapon, good tool, good act for flattening the curve. Since long in public health intervention, vaccine is a good thing to prevent the epidemic, but not for the patient who are now available, who are now with symptoms, who are now in ICUs. It is for the patient, it is for the people who are not still affected. And the vaccine is to create a subcutaneous shot which will train our body to recognize the SARS-CoV-2 and made our killer cell, natural killer cell, to produce available for producing antibody to neutralize the viral effect. But it needs time for testing, and meanwhile we have millions of patients. Side by side, we have to think, and I am hopeful that within very short time, the scientific community, manufacturers, businessmen, politicians are working day and night to invent and test a suitable vaccine. And also, we should think about the possible treatment option. Respected viewers, audience, and the policymakers, here truly, honestly, I would like to say that my objective to present and to share some information of COVID-19 is lies within this slide. To advocate this no, to advocate the no, to say no to play with azithromycin and to play with chloroquine, a decade-long therapy, anti-malarial therapy, a well-established drug and a well-established antibiotic, because we are in the paradigm of malaria elimination and chloroquine, a very effective drug for Plasmodium vivax. And if we playing with this drug, our possible elimination dream will be shunted and people will die, maybe not by COVID-19, but by people will suffer. Our elimination game will be hampered. And again, for azithromycin, after ciprofloxacin paradigm, most of the private practitioner, if we can, though I have not any scientific data regarding the prevalence of prescribing azithromycin, but informally I can say as a practitioner that he was after ciprofloxacin. And if he made this drug also um, unimportant and inefficient after playing with this drug, we also suffer a lot because drug resistance is antibiotic resistance a major problem in our country. And I am in the group of hardly say no to azithromycin and chloroquine as a choice of treatment of prophylaxis of, of COVID-19. And it is not time for playing with this drug. And in terms of prophylaxis, it is not proven by scientific research, scientific papers, no well established studies among the scientific community. So, in summary, I humbly request you all to be cautious about articulating these two names. And here is the optimism, and I think that the treatment options are now very much closer to our hand. As we learned that virus hijack the ACE receptor, use the cell machinery and kill the natural killer cell and make the person infected to others and make the lung fibrotic at such a stage of no return, and the catastrophe is going on. But as we are beginning to understand this complex biology of this virus, we have to understand our body, the host perspective, the host reaction. Our human body has a brilliant capacity to identify its invaders. We knew the first port of entry to the alveolar cell is the H2 receptor. And if we can block this entry by blocking and blocking the H2 receptor, we can block the entire cascade of the virus ability to use the engine and the machinery to regenerate and to do the catastrophe to our lung. And happily, luckily, now scientists are beginning to understand this ACE receptor through the power of genomics, through the power of supercomputing, and through the power of protein folding. This biology, this complex receptor is now well known. So we are able to make decoys and sponges so that virus is become as a Trojan horse and blocked at its point of entry. So this would be the first strategy of the treatment option. The second option, we may think that we can also block the underlying and the replication. As we know, the pathophysiology of the replication of this virus within the cell. And the third strategy, maybe we can block the endocellular packaging. And there are many scientists who are working on this. And the fourth option is to activate the natural killer cell to modulate our innate immunity of human cell to identify its invader. And how can we do this? In my later slide, I will explain. So these are the recommendation made in different papers, scientific journals, that we can activate our killer cell, our natural immunity by having straight, relieving stretch, by taking adequate rest, adequate sleep, regular exercise, and also there are recommendation of some respiratory exercise, which the respiratory experts can explain more. There are recommendations also to have vitamin C, 2000 to 3000 milligram per day, also the ionic forms of zinc acetate, and the mushroom is also recommended by many papers, many scientific journals, so that our host can act and counter-react the pathogen, the virus that attack. And hopefully, if we do this, many people can be saved from being transmitted or from mild to moderate, from moderate to severe, and from severe to critical stage. Now I am about to end my presentation, the scientific facts, not the fiction. However, before ending, I want to share some good story, the lesson so far been learned throughout the globe. There are lessons from Singapore, there are lessons from Vietnam, China, as well as South Korea. And for time consideration, I would like to share the four lessons the people can learn, the other country can practice the lesson from South Korea. The first lesson is the intervene fast before it's a crisis. That means just 1 week after the country's first case was diagnosed in late January, government officials of South Korea met with representatives of several medical companies. They urged the companies to begin immediately developing coronavirus test kits for mass production, promising emergency approval. Within 2 weeks, the Korean government confirmed cases remained in the double digit and thousands of test kits were shipping daily. The country now producing 100,000 test kits per day, and one official says they have a talk with 17 foreign countries for exporting those test kits. The second lesson we have learned from the Korean government, that test early and often and safely. South Korea has tested far more people for the coronavirus than any other country, enabling it to isolate and treat many people soon after they are infected. The country has conducted over 300,000 tests so far, and for a per capita rate more than 40 times that of the United States. And one of the officials said the testing is central because that leads to early detection. It minimizes further spread and it quickly treats those found with the virus. And he also said to BBC that the key behind their very low fatality rate is also the testing. The third lesson is contact tracing, trace and track. isolation, and surveillance. When someone tests were positive, health workers retrace the patient's recent movement to find and test and, if necessary, isolate anyone the person may have had contact with a process known as contact tracing and trace and track method, which seemed very effective in combating coronavirus. Were And the fourth and final lesson is the unleash the public health. When there are not enough health workers or body temperature scanners to track everybody, so every day people must pitch in. Leaders concluded that subduing the outbreak required keeping citizens fully informed and asking for their cooperation. Television broadcasts, subway station announcement, and smartphone alerts provide endless reminders to wear face masks, pointers on social distancing, and the day's transmission data. The messaging instills a near wartime sense of common purpose. The polls show majority approval for the government's effort, with confidence high, panic low, and scant hoarding. So here we can see the graphs that the position of South Korea, their case trend is going to be lower, and that's their curve is flattened more than other countries, and those were not the rocket science developed by South Korea or any new intervention or a magic thing. They have just applied the basic public health measures with some customization and with some digitalization. And that is the key. They have done it very timely, very early, and very proactively. So, everywhere, after 1 month of lockdowning, most of the people of all age are asking how long we'll be locked out and lockdown will continue. And no answer, basically, because the answer is depends on our individual and collective actions, our effort from government, of course, and again from the private organization, people, and the donor community. Here we can see a graph of different epidemics documented. Smallpox in 1937 at California, rubella 1971, mumps 1973, hepatitis A epidemic 1980, pertussis, which is only bacterial diseases, influenza, measles, chickenpox, polio. Most of the viral epidemic starts at the late of November, continuing December, January, February, March, April, and almost May. So we expect at the end of May and our collective and individual action will be free from this epidemic, and time will say how can we end, how many lives we can save, how many people we can save from being transmitted and from being died. Again, as a optimistic person, I would like to end my presentation with the hope that the sun will be rising, morning will come with a new normal scenario which will be a shifted society with shift in economics, politics, and with shifts in lifestyle. And lastly, I also pay my cordial condolence to the deceased who have been died by these epidemics, and of course, my colleague, late Dr. Moinuddin, who have been died during his work by the contamination during his work. And I also pay my condolence to his departed souls. I hope that his family will be able to able to maintain their normal life in absence of him, and he will be laid in the heaven. Thank you all.